Hello friends, my name is Samir and welcome back to another video. This is chapter 4. In chapter 4, we are going to explain about valency and variable valency. Before going to start our class, once we revise electronic configuration. Yeah, electronic configuration. The systematic arrangement of the systematic arrangement of atomic orbitals in the increasing order of their energies. In the increasing order of their energies is called electronic configuration. If you want more explanation on this, watch chapter 3 on YouTube. Let's start our class chapter 4. Valency. Valency. Valency definition. The combining capacity of an element. Combining capacity of an element. Or, according to the new books, the definition of valency is going to be changed. The number of electrons an atom can gain or lose or share to acquire stable electronic configuration. To acquire stable electronic configuration of the nearest noble gas element. Nearest noble gas element. Write the definition. As per old books, the definition of valency is combining capacity of an element. Combining capacity of an element. According to the new books, the valency definition is the number of electrons in an atom can gain or lose or share to acquire stable electronic configuration of the nearest noble gas element. Nearest noble gas element. Example Na plus. Na plus lost one electron to become stable. So the valency of sodium is 1. Valency of sodium is 1. Clear? According to the old book, the valency definition is combining capacity of an element. According to the new books, the number of electrons an atom can gain or lose or share to acquire stable electronic configuration of the nearest noble gas element. Example sodium, valency of sodium is Na plus. Okay. Now we are going to learn valency of metals. Valency of metals. Definition of valence of metals. The number of valence electrons present in a metal atom is called valency of metals. Valency of metal. The number of valence electron present in a metal atom is called valency of metals. Valency of metals. Clear? And note this point, it is very important. Valency of metal possess 1, comma 2 and 3 valencies. Valency of metal possess 1, comma 2, comma and 3 valencies. Example: sodium, magnesium, aluminium, etc. Sodium valency is 1, magnesium 2, aluminium 3. Clear? Up to here. Valency of metal is equal to the number of valence electrons present in the metal atom is called valence valency of metals, and the valency of metal possess 1, comma 2 and 3 valencies. An example: sodium, magnesium, aluminum, etc. Now we are going to learn valency of non-metals. It is very simple. Can I tell? There is no definition for that. We have only one formula. Valency of non-metal is equals to 8 minus number of valence electrons. 8 minus number of valence electrons. Okay. Valency of non-metal. Valency of non-metals is equals to valency of non-metals. Non-metal is equals to 8 minus number of valence electrons. Clear? And note this point. Valency of non-metals possess 4, 5, 6, 7 valencies. Example: carbon, nitrogen, oxygen, fluorine. Clear? And carbon valency 1s2, electronic configuration 1s2, 2s2, 2p2. It has 4 valence electrons. Then 8 minus 4. Then the valency of carbon is 4. And you should want to tell me what is the valency of nitrogen, oxygen, fluorine. Tell me in comments first. Note it, guys. Clear? Now we are going to learn variable valency. Variable valency. If a element has more than one valency, it is called variable valency. If a element has more than one valency, is called variable valency. Variable valency. If an element has more than one valency, is called variable valency. Variable valency. Example: iron, copper, etc. etc. Mostly transition elements possess variable valency. Mostly transition elements possess variable valency. Write it. Clear? Here we are talking about variable valencies. In that we learn the definition. If element have more than one valency, then it is called variable valency. Then we have a doubt. If element has more than one valency, then what we call? Yeah, what we call? I am telling. Note that points. Write it. The compound. The compound in which the element shows higher valency is called, sorry, higher valency, then it is indicated indicated as IC, suffix indicated as indicated suffix IC. Clear? IC. If the compound has lower valency, then the suffix is VOUS. The suffix is VOUS. Write it. The compound in which the element shows lower valency, then it is indicated the suffix VOUS. Remember these 2 points, because these 2 points are very important. Very important. Okay, up to now here clear. If element has higher valency, then it is suffix is IC. Lower valency means VOUS. Remember that. Okay. And we have the few examples on those 2 points. Now I am going to write. Listen. Element valency, name representation, example. Element copper. First element is copper. We take valency 1 and 2. If the valency is 1, name is cuprous cuprous. If the valence is 2, name cupric. See here, if the valence is lowest, OUS. If the valence is higher, IC. Okay. Representation: copper 1, copper 2. Example: Cu2Cl2, Cu2Cl2 and CuCl2. Clear? Note it. And second example, iron, we are going to take iron valency 2 and 3. Name: it has lowest valency, then ferric, so ferrous, higher valency ferric, OUS, IC. Clear? Representation: iron example FeCl2 and FeCl. Clear guys up to here? Note it. And if you want more examples, you can see there is a table here. Yeah, here. Okay. Note it. Over guys. Now we are going to learn about variable valency of nonmetals. Listen properly. Variable valency of nonmetals. So definition: variable valency of nonmetals is due to extension from S or P subshell to vacant d orbitals. Listen properly. Variable valency of nonmetals. Listen properly, this is very important. Variable valency of nonmetals due to extension of from S or P subshell to vacant d orbital. Vacant is nothing but empty orbital. Clear? Before going to start the variable valency of nonmetals, I will tell, yes, this is the orbital of S, and P orbital like this, and D clear, and F orbital 1 2 3 4 5 7. Yeah, and S orbital holds 2 electrons, P holds 6, 1 2 3 4 5 6, and D orbital holds 10 electrons, 1 2 3 4 5 6 7 8 9 10. Clear? f orbital 1 2 3 4 5 6 7 8 9 10 11 12 13 14. It holds 14 electrons. Clear guys up to here? Clear? Now we are going to do an example on this. Once again I am telling the definition of variable valency of nonmetals. Variable valency of nonmetals is due to extension. Remember this point. Extension from S or P subshell to D vacant d orbitals. Vacant d orbitals. Clear? Now we are going to take the example sulfur. For example, sulfur. Write the electronic configuration of sulfur. Electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p4. And the valence electrons of sulfur is 6 valence electrons. Then write the electronic configuration of sulfur in ground state. Ground state is C. Did you remember this point? We taught 3d0. The electronic configuration of sulfur in ground state is this one, and in ground state sulfur valency is 2. How bro? How the valency of sulfur is 2? Because it has 2 unpaired electrons. In ground state of sulfur has 2 unpaired electrons, so the valency of sulfur is 2. In ground state, valency of sulfur is 2 due to it has 2 unpaired electrons. Clear? Now, electronic configuration of sulfur in first excited state. Now, again we want to write like this. One, two, three. One, two, three, 1, 2, 3, 4. Okay, listen. Are you thinking that how here one electron is came in d orbital, in 3d orbital? Listen, we are transporting s orbital from one electron from s orbital to d orbital. Then that is called first excited state. Then 3s1, 3p4, 3d1. Okay, listen. In In first excited state, sulfur valency is sulfur valency is 4. Why? Due to due to it has 4 unpaired electrons. Due to it has 4 unpaired electrons. 4 unpaired electrons. Clear? Clear guys up to here? Listen. No. Then electronic configuration of sulfur in second excited state. Second excited state. Excited state is nothing but transport of electron from one subshell to another subshell. Clear? Electronic configuration of sulfur in second excited state. Second excited state. Okay. Now here one electron, one, two, three, 1, 2, 3, 4. Clear? We transport one electron from P to D. Clear? 3s1, 3p3, 3d2. Then tell me, how many unpaired electrons have sulfur in second excited state? There are 6 unpaired electrons. The valency of sulfur in second excited state is 6. Due to it has 6 unpaired electrons. 6 unpaired electrons. Valency of sulfur in second excited state is 6. Due to it has 6 unpaired electrons. 6 unpaired electrons. Clear? Up to now. Up to now clear guys. And now we are going to do few sums. Question number 1. How many valence electrons are there in nitrogen? Then first write the electronic configuration of nitrogen. 1s2, 2s2, 2p3. Okay, and there are 5 valence electrons in nitrogen. 5. Clear? Okay. Now question number 2. What is the valency of oxygen? What is the valency of oxygen? Oxygen is a non-metal, so the valency of oxygen is simply, we can say, 8 minus number of valence electrons is the formula. So now do oxygen electronic configuration. 1s2, 2s2, 2p4, 5, 6, 7, 8. Okay, clear? And it has 6 valence electrons, so 8 minus 6 is 2. Then oxygen has 2 valency. Oxygen valency is 2. clear, and it has 6 valence electrons. Okay, now hmm, question number 3. Valency of valency of hmm, calcium. Valency of calcium. So here calcium is a metal. So what is the metal definition? Number of valence electrons present in a metal atom. Then it is called valency of metal. So we should want to write the calcium electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, argon 4s. Clear. It has two valence electrons. So the valency of calcium is 2. Is And finally we completed our chapter 4, and that's it for today. Bye bye guys. Wait, for more chemistry videos, subscribe to our channel SEW Classes.